Welcome to today's tutorial. So in this tutorial we are discussing a question from an exam paper. It's also under graphs of polynomials. Alright, so it's a very simple question. If you have not yet subscribed to the channel, make sure that you click on the subscription button so that you don't miss the videos that I'm going to be posting, and don't forget to click the notification button. It will also help to be notified whenever I post anything on my channel. Alright, so if you have any questions, feel free to contact me using these lines on the screen. Okay, so this is a question and it's asking us to sketch at some point. But when you look at my graph paper, it's not a standard graph paper, so I'm just using it to show you how to solve such questions. Okay, so let's quickly begin to solve. So the question is the values of x and y are connected by the equation y is equal to x cubed minus 5x plus 3x plus 3. Some corresponding values of x and y are given in the table below. So these are some of the values that have been given, and then the first question says calculate the value of k. And then the second question says using the scale of 2 centimeters to represent 1 unit on the x-axis for -3 from -3 to 3, and 2 centimeters to represent 5 units in the y-axis from -10 to 20, draw the graph of this equation. So this is a very simple question. I'll show you what these scales mean and how to interpret them. And then the third question says use your graph to solve the equation of the equation that has been given here. And B says estimate the area bounded by the curve y is equal to 3 and the line x is equal to -2. And then there's also this other question which is just totally different from it is just totally different from these. So I'm also going to solve it just to help you know how to deal with it. Alright, so we have the first question says calculate the value of k. So to find the value of k, you get the same equation that you've been given. So the equation given is y is equal to x to the power 3 minus 5x plus 3. So we've been given the value of x there, which is -3. You just replace it where there's x there to find the value of y there. So to find k, so in other words, k is standing for y in this case. So what you do is, instead of putting y there, you can even write k there and say k is equal to, while there's x, I'm putting -3. So I'll put -3 there, I'll raise it to the power 3, minus 5, while there's x, I'm putting -3, then plus 3. So my k is therefore going to be equal to, so -3 raised to the power 3 is just the same as -3 times -3 times -3, and -3 times -3 gives you 9. 9 times -3 to give you -27. So we put -27 there. -5 times -3, we're getting positive 15. And then we have positive 3 there. So when we add when you add -27, so when you add -27 and 15, you also add 3, you get the answer to be -9. Hence the value of k is -9. Okay, so -9 is the value of k. So we have -9 there as our solution. Alright, so let me just put -9 where this k. Alright, so we have solved the first part, which says find the value of k, meaning you've gotten 1 mark from the exam. Alright, so let's quickly move on to sketching. This is a part which is sensitive, which I want you to pay particular attention. Alright, so it says using the scale of 2 centimeters to 1 unit, 2 centimeters to 1 unit on the x-axis or to represent 1 unit on the x-axis. So they're saying 2 centimeters, meaning one box. I'll take 3 boxes to represent one box according to the standard. Okay, the standard graph paper has these kinds of boxes. It will have one box, and this box will have about 10 smaller boxes inside there. So even there you have something like this. That's the standard graph paper. So now this box, which contains 10 boxes inside there, I'm going to I'm going to take 3 boxes, or let me take 4 boxes. Okay, so meaning it's supposed to be like this. So I'll take something like this, one box to have 4 by 4. So a 4 by 4 box will represent those 10 those standard ones. This is just my scale, and I want it to match with the standard graph paper that you mostly use. Alright, so I'm going to take these 4 by 4 boxes as my 2 centimeter, and that will be representing 1 unit in the x. So meaning a 4 by 4 box will represent 1 unit in the x. So, and this same 4 by 4 box will represent what? 5 units in the y-axis. Alright, so let me do the same. Let me draw this. So I'm saying, so let's start with the x first. So the x, we have 2 centimeters representing 1 unit, and we have to move from -3 to 3. So we have 1, 2, 3, 4, 5, 6. So I'll move it a bit this side. So in other words, so here don't forget we have -9. So I'll start from here. So 1, 2. So every after 4 boxes, I'm counting 1 unit. 3, 4, 5, 6. Okay. So if this is my 3, 2, 1, 0, -1, -2, -3. Okay. And then going up, I'm just drawing. I'm just making. What's this? I'm just putting up. I'm just trying to give you an idea of how you are supposed to be thinking when you're about to sketch. Then in the y, we've been told that we are moving from -10 to 20, and we have to be moving by 5 units. So every after a box, every after 4 boxes, which is equivalent to my 2 centimeters. That's if you're using a standard graph paper. It's equivalent to 2 centimeters according to my graph paper. Yeah, so 4 boxes will represent 5 units according to me. So I'll say 1, so this will be 5, 10, 15, 20. Sorry, so this will be 5, -10. So 0, 5, 50. Okay, to be, I just wanted to see where 0 should be, so I'll put my 0 somewhere there. So I'm going to draw the XY plane. I just wanted to know where I should put my center on the graph paper. So I'm connecting these 2 points with zeros. So you're supposed to use a ruler when drawing these. So I'm not going to be very much accurate because I'm using freehand. Okay, so now I can put in my numbers. So it's very simple to do this. So you have x, then you have y. Then this is my center, this is where my 0 is. Then going this side, I'm supposed to have, okay, so we have 4 boxes representing 1, 2, then my 3 will be there. This side we have 1, 2, 3, 4. So we have -1, negative 2, negative 3. Okay, and then going up we have so going down 1 2 3 4. So here we have negative 5, then we're ending up to negative 10. 1 2 3 4. So negative 10 will be somewhere there. So we start 1 2 3 4. We have 5, 1 2 3 4. We have 10, 1 2 3 4. We have 15, 1 2 3 4. So we have 20. So we're supposed to end at 20. So you follow the scale that has been given there. So now we start plotting, we start putting in the coordinates that we have. So negative 3 comma negative 9, negative 3 comma negative 9. I'll approximate my negative 9 to be somewhere there, because but if you are using a graph paper with those small boxes, you know where negative 9 is with no doubts, of course. So if this is 5, so this should be 7.5 there. So negative 9, I'll approximate it to be somewhere there. Negative 2 comma 5. So negative 2 comma 5, it's there. Then we have negative 1 comma 7. Negative 1 comma 7, I'll approximate it to be somewhere there. 7.5 is there. So 7 can be somewhere there. And then 0 comma 3. 0 comma 3. If this is 5, 3 can be somewhere. So 2.5 is there. So 3 can be somewhere there. And then we have 1 comma negative 1. 1 comma negative 1 can be somewhere. So this is 2.5. Negative 2.5. Meaning 1 can be somewhere there. So this is 1 comma negative 1. Negative 1 can be somewhere there. And then I don't know, but why this is not coming out as, anyway, let's see. So negative 1 comma negative 1, 2 comma 1. So 2 comma 1, 2 comma 1, 1 can be somewhere there. Oh, sorry. So it should be somewhere. 1 should be before that. So 1 should be somewhere there. And then 3 comma 15. So 3 comma 15. 3 comma 15 is somewhere there. Oh, 15 is there. So we can now just connect the points. So connecting the points, we have, like I said, for you, you're supposed to be a bit accurate because you'll be using a standard graph paper. So I'm not using a standard graph paper. That's why you are seeing me bending like this. Alright, so we have managed to sketch our graph. So now, after sketching the graph, we have gotten 3 marks. Just doing this, you have gotten 3 marks. So you have to make sure that you indicate that this is the equation for this is y is equal to x to the power 3 minus 5x then plus 3. And then from there, you also remember the question says we answer the whole question, this whole question on the graph paper, meaning even finding the value of k should be done on the graph paper. You write it somewhere there. Then we go to the third part of this question, which says use your graph to estimate, or rather to solve the equation. So solving this equation using this graph. So when you look at this equation that you've been given and this one, they are a bit similar to some extent. Alright, so let's see what is similar. Let's see what is the same in these two equations. So the first equation is, or the given equation is y is equal to x to the power 3 minus 5x plus 3. And then this other part we have 0 this side, and then we have 3 to the x to the power 3 minus 5x. So if I want this equation to be the same as this on the right, I'm supposed to take this 3 to the other side of the equal sign. So I'm going to have something like this: y plus 3 is equal to x cubed minus 5x. So I've transformed this equation into that one. So I've just taken 3 to the other side of the equal sign. So if this part is equal to that part, so if these two parts are equal, it means that these two parts are also what? Equal. Sorry, this one is supposed to be minus 3, since it was positive on the right. When it crosses the equal sign, it's going to be minus. So if this one and that one are equal, it means that this one and that one will also be what? They will also be equal. So now how do you solve, or how do you, so if this part and this part are the same, it means that 0 is also equal to, so we say y minus 3 is also equal to what? 0. This 0 is also equal to that. So we are going to take this 3 to the other side of the equal sign, meaning you are going to have y is equal to positive 3. So if y is equal to positive 3, how are we going to find the solution on this graph paper of this line? So it's simple. How do you do that? You just go where there is y is equal to 3 and draw a line. Where the line is going to meet the curve, those are the solutions, or that's where the solutions lie. So we look for 3. So here we have 2.5, so 3 should be somewhere there. So at 3 I'm going to draw a straight line. Okay, so at this point, this is where our solution is, and then we also have this point, that's where our solution is, and then we also have another point, which is this one, that's where our solution is. So the first solution is this one, so negative 2. So this should be negative 2, so this is negative 2.5, so this can be negative 2.4, somewhere there. So my first x value, so the first x value, x is equal to negative 2.4. Then this one should be 0. If this is 2.5, if this is 0.5, this should be 0.25. So the other x value is negative 0.25. So these are just estimates. You are not getting the accurate answers. But if you're using a graph paper, you'll be more accurate than me. And then this other part is 2.25 as well. So we also have 2.25. So we have another x value as 2.25. So we have found this one as well. So we've managed to get 2 marks. We move on to finding an estimate of the area bounded by the curve and these two lines. So now how do you find that area? So let us locate that area. So y is equal to 3. This is the same line that we have drawn here, and then y is equal to, x is equal to negative 2. So x is equal to negative 2. So x is equal to negative 2 is this one here. So x is equal to negative 2 is this line here. So now they are asking us to find the area bounded by this curve, and then apart from that, this line, this line, and the curve. So meaning we're finding this area here. So how do you find the area of that part? So the area of this part, I think we're finding this area, and okay, so how do you find the area now? So we use the trapezium rule. So how do you do that? You divide your given you divide this same part here into trapeziums. So you can divide it into as many trapeziums as you can, or parallelograms, you still find the same answer. So right now let's do that. So we divide this. I'm going to divide it into 2 so that I have this one which looks like a triangle, and also this trapezium here. So I have area A and area B. So to find the total area, I'm going to add area A plus area B. So this is now going to be so area A is a trapezium, and the formula for a trapezium is half A plus B times the height. So the height is the distance from there to there, and then the A is this part, B is the longest part, which is this one. And then when you look at area B is a triangle. So the triangle, the formula for a triangle is simply just half base times height. So the base is the distance from there to there, the height is the distance from there to there. So let us now put in the values. So we have half, the value of A, the distance from there to there is, so we have, this is 3 to 5. We said this is 3 to 5. So this distance here is 2. So 5 minus 3, you get 2. Then we say plus B, which is the longest distance, this point here, which is almost like the turning point of this curve. So this is like so this is, we have so we can get this as what? We had this coordinate, which is -1 comma something comma 7. So we said if this is 7, so I can count this as 7.5 somewhere there. Okay, I'm going to get it that way. So I'm going to say plus 7.5, though it can even be if this is 7, yeah, okay, let me just put it 7.5. Yeah, this is an estimation. You are not finding the accurate answer, no. And then from there, the distance from here to there is the one that we're calling the height, from this point to that point. So the distance, if this is 1, this should be 1.1 1 point. If this is 1.5, this can be 1.1 somewhere there. Okay, or 1.25, yes. So this should be 1.25, not 1.1. So this is 1.25. So 1.25 and this is 2. So when you subtract 1.25 and 2, you get 0.75, meaning the distance from here to that point there is 0.75. And then we add it to the area of a triangle. So the base of a triangle is the distance from this point here, which this point here we estimated it as 0.25. This point is 0.25, and if you're using a graph paper, a standard graph paper, you find it easier to find these numbers that I'm writing here. But here we are using a graph paper with big boxes, so it's a bit difficult to pick out the numbers. So if I get this as 0.25, this one should be, we said -1 point what? 25. Okay, so we say so we subtract 1.25 minus 0.25, which is just 1. So we're saying times the base, which is 1, then the height is the distance from there to there, which we said this can be what? Okay, so it can't be 7.5. 7.5 is the distance from 0 to that point, meaning the distance from this point to that point, we subtract this one, which we said 3 minus 7.5, which is going to give us, so 3 minus 7.5, it will give us 4.5. So we are multiplying it by 4.5 as our height. So we can say half. So 2 plus 4.5 gives us 6.5, and then 0.75. Then apart from that, we add it to half times 4.5. So when you multiply 6.5 times 0.75, and then you divide this by 2, you are getting 2.4375. So if you are using a calculator, you get 2.4375. Then you're adding these two. 4.5 divided by 2, which gives you 2.25. Meaning the solution is, when you add 2.25 plus 2.4375, you're getting 4.6875. 4.6875. So this is the area. You say units squared. So this is the area, the total area of this shaded part here, the one that we've been asked to find. Okay, so the area, the total area is simply just 4.6875. Alright, so let's see how we can solve the last part of the question here. So I've helped you to solve question 12, which involves sketching the graphs of polynomials. So let's now look at how we can find the equation of the tangent to the curve, this one, at the point where x is equal to -1. It's also very simple.